Hello ladies and gentlemen, this is FreeHomeBrew, here to bring you the video on line fractals. So as announced, I was going to do a video on fractals, on my fractal generators, and this is that video. So first I'll explain what I'm going to do with these lines to make them into fractals, and then I'm going to dedicate some time to the source code once again. So I start out. I've got line generators, fractal generators that use line replacement rules. So I take a line, apply some rules, and then I replace that line with the newly generated lines. So this one also works recursively. So bear that in mind. The replacement rule is as follows. I take a line, I cut it in half, and at the midway point I take its normal, so the line that's at 90 degrees relative to the original line, and I take a point along that vector, along the normal axis, and mark it and replace the black line with the two red lines. So yeah, that's basically how it works. The random factor is in the distance it will travel along this axis. So and it will end because this axis is the maximum value along this axis is such that this new line will have the length of this line. So it will be finite. So this line will never be of the length of this line. At maximum it will be like this length maybe, and due to that these lines get shorter and shorter, and there's a lower boundary after which the algorithm will no longer break the lines, the subsequent lines. So as long as a line is of a certain length, it will still break them up. So let's see the replacement rule applied to the next line. So we take a point, we take the midpoint of the red line and break it in half, and then add a point and draw two lines to it. So now we have the green line, the two green lines and the red line, and we break the green line again, and we get the next point. So it can move in either direction, and this is how it will continue. So this is basically the algorithm for the first fractal generator. The second one uses orthogonal lines, if I'm pronouncing that correctly. It's horizontal and vertical lines broken up into squares, and these squares are then extruded and cause new lines to be put in there. So I take 2 points along this line, and I select one of these sections. So either this section, or this section. This may be on random. This may be the shortest section. There's several options for this generator. So I'll just pick the shortest one, and I extrude a square. Here I take this point, this point, this point, and this point, which form a square, and then I take away, then I take this point and append these 4 points in between, and add this point at the end. So I replace these 2 points, more or less, these end points, with a list of these 6 points, this point, these 4 points, and the next end point. Then we have now we have 6 lines. Now we have 5 new lines, 1, 2, 3, 4, 5 lines, which I can also break into new points. So let's go ahead and do that. So we've got new points pointed along these axes, along these lines, and we will break them at the shortest sections. So that's these yellow sections. Yeah, so let's look at the replacement rule, and there we go. There you have it. That's the second replacement rule. So this will generate another set of fractals. So we can break this line, and all of these lines can again be subjected to these rules. So it will generate another fractal. So we've got these rules and we've got these rules, and now we can take a look at the fractal generator itself. And I'm just going to run it for now because I don't have any examples. it's outputting some images, 50 of each. So I'm just gonna wait for that to finish. Yeah. Let's see now. Images. Nope. Here we go. So this is what you get when you use the first one, and this is the second one. These are all examples. The first 50 images are examples of what you get for the first fractal generator. So you can clearly see it's very random. So yeah, if this were the surface of a landscape, you'd have overhanging cliffs, caves, caverns, and mountain tops. Even some freaky patterns like this, but this can be avoided using parameters. So let's just skip a few and see what we get from this generator. So the end condition is that it won't break lines of length 3 or less, I think. Maybe more. And these increase in recursion depth. So yeah, it's the same as in the update video. As we can see, let's skip a few back. So we've got the baseline, and it took this section over here and extruded this one, and then it took this line and extruded this section, and then it stopped. Same with this area over here. So it's always a square extrusion. I chose a square because for the loss. So I thought that was an interesting feature. Let's go ahead and skip these to see where this is heading. I like this one a bit because you can see this one will also generate cavernous areas. So you could use this for maybe a dungeon or a futuristic robot society kind of game. Let's see. I'm at 40 now, almost through all of them. Yeah, it was that. So this one has the highest recursion depth. So yeah, that's that. Let's go see the source code. That's really what we're all in here for. I just take some random stuff. I don't need everything. This is an import from another piece of software I wrote. So not all of these imports are required. I don't think I need any of the math operators. I need I need this random one, and I don't need the HSV to RGB. So I need Pygame for the images export, and I need the random for the for the noise. This is an image writer. This basically exports the image of the fractal. This one as well. Okay, here we go. This is the line breaker, and this is the recursive line breaker. So I'll first get into this one. I take 2 points, 0.0 and 0.2, because I'm going to add 0.1 in the middle. So I take 2 endpoints and I add a point in the middle, which will be translated along the normal axis. So I've got a dx, which is the difference in x coordinates between these two, and a dy, which is the difference in y coordinates, and a d, which is the distance, which is the square root of the difference in x and the difference in y squared. So these are all basic principles you learn in math class. So L is the limit of the length of the line. So if the line is smaller than the L, it will just return these 2 points. So that's if the line is smaller than L, it won't break it. If not, it will proceed with this bit over here. N is the normal vector, which is dy over d, comma dx over d. So I think I missed a minus in here. Anyway, this is the normal vector, and it doesn't matter either way. Probably I need a minus over here. nd is the normal distance, so it will travel this distance over the normal. And we can see the random is a value between 0 and 1, and minus a half means it's a random variable from minus a half to plus a half. So this is the distance it will travel over the normal vector. And this is a unified normal vector because the d is it's over d. So it takes the absolute distance difference and divides it by the actual distance over these points. So these are all both values between minus 1 and plus 1. So point 1 is defined as the previous point plus dx over 2, which is the midpoint between these first 2 points. Let's see. In the images I had, this one. Yeah, so not this fractal, this fractal. So we take the midpoint, and then we have the normal vector, and we add some distance to it, and this distance will form, and this is then the new point that's added to the list. So we've got point 0 and point 2, and this is point 1. Let's see here. Yeah, point 1 plus a normal then a normal distance times the normal vector, the x-coordinate of the normal vector. So that's basically how a line is broken in this line generator. And now I think I'm done with this one. This is RL break. L is for L break is line break. RL break is recursive line breaker. So yeah, that's just my way of doing things. Takes the same arguments, takes the same methods up until here, and then it will return I for I in RL break P0.1 and 0.1 and 0.2. So what this does is it breaks a line it gets, and what it returns is the broken lines between point 0 and point 1 and point 1 and point 2. So it's really easy to understand if you watch. So it takes these 2 points and it will return these point 0, 1 and point 2 and every point in between, which it generates using the same function. So it will return all points between 0 and point 1 and between 0 and point 1 and between point 0 and point 1 until it reaches the recursion depth or the minimum length of a line. So we got a list of points over here and a list of points over here and here and here, and that's because it always hits the bottom of length 3. In this case, you can define this length. Because it always hits the bottom, it always returns a list of points, a finite list of points, and hence it will end. So yeah, that's the first line, the first fractal generator. I hope this makes sense to you, especially if you're a mathematician. This should make sense to you, except how I name my stuff. This is the right angle line breaker, hence the right angle line breaker. Sorry for naming my stuff so awkwardly. We still have the point 0 and point 1, point 2. Let's see, that's these 2 points. We still have the dx dy and the distance and whatnot, this limit. If the distance is smaller than L or dx times dy is greater than 0. I added this condition because if the line is horizontal, dx will have a value, but dy will be 0. So dx will be greater than 0 and dy will be 0, which means this will evaluate to 0 if it's horizontal, which means this condition will not be met, which means only if the line is smaller than L will it return these 2 points. And if the same case is in the reversed case, when it's a vertical line, this one is positive and this one is 0. So this will evaluate to 0 in either horizontal or vertical lines. So if this is 0, it's not greater than 0. So if this is greater than 0, both of these are greater than 0, which means we don't have a horizontal or vertical line. So this tests if a line is askew, in which case it will return these 2 points. In which case it hence won't break the line. So let's see that in action more or less. We take, for example, if we take these 2 points, these are not on a vertical or horizontal line. So this is greater than 0, so it will not break anything in between these 2 points. So that's what this condition means. Continuing, like I said, I take 2 random points, A and B, and C is then the maximum of those 2, and A is the minimum of A and B. So C is, and then B is C. So what this does is I take these 2 points, I take the C is the maximum of these 2, so C is this one, and then A is the minimum of these 2. So A is either, if the green arrow is over here, then A will be this one, but we already stored this arrow in C. So if we then set B to C, we always have A on the left and B on the right. So B is always greater than A due to these computations. Bit of shadowing going on here. L is a list of distances. L is the distance A minus 0, i.e. this distance, B minus A, i.e. this distance, and 1 minus B, i.e. this distance. If L is 0, L is then the index of the lowest value in this list. So it takes the shortest distance and then the index of that. So this is a method of selecting the smallest piece of line, basically, smallest segment of this line. If L is 0, i.e. when it's the left part, B is A and A is 0. So we shift the red arrow to the green arrow and the green arrow to the left. And if L is 2, we do the opposite. We do the green arrow to the red arrow and then B is 1. So the red arrow will be moved to the end. And if L is 1, so if it's this area, A and B don't have to be moved. The distance is B minus A. These are the fun computations. Point A is this point, let's see, point A, B, C, and D. So we've got point 0, which is this one, A, B, C, and D, and point 2. And we take lines between those. See, this line, this line, this line, this line, and this line. So those are these lines. Now to the definitions of these points. We have the left perspective for all of these points, so it's all relative to this point over here. We take point A, the first point, and the x-coordinate plus A times the x-coordinate, and another one A times the x distance, and B times the x distance, and B times the x distance. Because A and B are smaller than 1, we'll always end up in between these 2 points. So point A times dx, and point B times dx, A times dx. So point A and B are at the same x-coordinate as are C and D, so which is the red arrow. So C and D and A and B are at the same y-coordinate, x-coordinate. And then we have the y-coordinates is P0, 1, so the y-coordinate of the left point, plus A times the dy, and B times dy. Oh wait, I still haven't explained this part. So D is the difference between A and B. So after even moving these parts, so this will ensure that the distance, this will ensure that this distance is equal to this distance over here. That's basically what this D does. So we add we add dx times a, which is this point over here, and then d times dy. And this may seem peculiar because we add a dy to to an x-coordinate. Why would we do that? This is because if the line is horizontal, dy will be 0. So this will evaluate to 0 in horizontal lines. But if it's vertical, it will evaluate to a positive value or negative value. Either way, it will evaluate to a non-zero. But in the vertical case, this will evaluate to 0. So we only add this distance over here. So this means that if this image were 90 degrees rotated, we'd end up with the same concept. So we don't need if and else statements because dx and dy evaluate to zeros and ones on their own. So this is a really neat feature in this piece of software. The same goes for the y coordinates. The same principles apply. So only the dy and the dx are switched. So this takes care of both horizontal and vertical lines, of which I'm pretty proud, because I saw this in advance before I wrote the if and else statements. And this is the single line breaker, and now we have the recursive line breaker. It does the same stuff, and it has a few things added to it. Line 1 extrudes the smallest section, which is this. Line 2 extrudes the longest section, just minus and max exchanged. And line 3 extrudes a random section, so floor of random 3. So this value will be 0, 1, or 2 at random, from which it will then select using this a random area. So this is the same. Disabling both of the following lines will always extrude to one side. Oh yeah. Let's see. D is B minus A. In this case, D is B minus A, so D is the distance between the 2 points. And the first line swaps the extrusion direction per recursion level, and the second line will swap at random. So this is the direction in which it will be extruded, so i.e. to up or down. You can extrude in either way, either direction. Depth is the recursion depth. Modulo 2 means if it's odd, this is 1. If it's even, this is 0. So it's either 0 or 1. Times 2, so it's either 0 or 2. Minus 1 means it's either minus 1 or plus 1. Times d means d is either positive or negative d. So this is pretty nifty. And this one swaps at random. So it's basically the same idea. This is between 0 and this is minus 1 or plus 1 at random. It's not actually, I think, because it can evaluate. This can evaluate to 0, so I have to fix that. Maybe not. And then this is the same. PL is a point list for this line. This is the replacement point list, and the replacement point list will be a set of lines here. This is shadowing occurring here. So we've got this list of points. We need lines in between, and we will pair these in a new list. So PL will be replaced with a list of pairs of these. So this is the first pair, this is the second pair, this is the third pair, fourth pair, fifth pair. So this is a list of pairs of points. PLL is empty. For PL and PLL, for I and PLL, PLL will be appended with RAL break for the first pair. So it will reapply the recursive line breaker for these pairs in PL. So for every pair in PL, it will recursively break these lines in the same way. And because we still have this condition, it will be finite. See, I've also added this condition here if the depth is the maximum recursion depth. So it's a finite list. So this is basically the same as the let's see. So this is basically the same as this one, where the points are. We only had to deal with 2 pairs of lines over here, so I named them explicitly in these 2 pairs, and this one over here does the same thing for these 5 pairs. So that's basically what that is. I've got some running stuff over here. This one is a function I was meaning to implement to show the in-between steps. It doesn't work with recursion. And then here it runs examples. Yeah, 50 of the first one, 50 of the second one. So that's that. Okay, I think we're through the source code of the line generator. So I'm gonna wrap this up. Feel free to comment, ask questions, like, rate, subscribe, whatever. And I will see you in the next video. Bye.